Okay, I made another mistake. Right here, there should be -2 is the center. So the center is -2. Okay, with practice, you can see that right at the beginning, right? You got this, where is it? Oh, right here. Okay. From here you can see center equals -2. So what is it? It's the x value that makes this item equal 0. Okay, what was I talking about? Oh, yes. I wanted to explain to you something or other. Interval of convergence. Why? I don't know. So what do I know so far? I know that if I choose an x value strictly between -7 and 3, I know that if I plug that x value into this series, then I will get a convergent series. Because that's what I know so far. But what happens if I plug in, what if I plug in -7 itself, or 3? What's going to happen then? Well, I don't know. At this point, I don't know, right? Because this is the shortcoming of the ratio test, is that it doesn't tell me what happens when L equals exactly 1. Okay, so I have to investigate those individually. So we'll call this checking endpoints. Check endpoints. -7 and 3. Okay, so I'm going to plug them into I have to do it kind of the long way, the hard way. I'm going to take these two numbers, plug them into my original series, which I'm scrolling up to, plug them into my original series, and then see what happens. Let me just copy this lovely thing. What? Copy, I say. No. You don't want to copy? Okay, fine. Okay, I think I got it. Checking endpoints. So I'm going to take x is equal to -7, plug it into my original series. -1 to the n. X plus 2, so -5 to the n. Square root n plus 1. So I took my original series, plugged in x is -7, and now I have to see if this is C or D. So if it is convergent, then I will include -7 in my interval of convergence. Otherwise, not. So what do I get? Simplifying. What happens? So I get, on top, I get -1 times -5, all to the n, or 5n plus 1, blah, 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 and then I just get, well, this is just, that cancels with that. It's the same thing. So I get summation 1 over root n plus 1. So what is this guy? Well, I'm suspecting divergence here because it's, it's going to be p is equal to half. That's what I'm thinking. But I'll do a quick comparison test. This is bigger than 1 over root n. Bigger? No, it's smaller. Smaller, bigger, smaller, It's smaller. That's not good. It is bigger than 1 over root n plus n plus n. Okay, which is over 2n, which is 1 over root 2 times root n. And and summation 1 over root 2 root n is convergent since, nope, divergent. It's divergent since p is equal to so summation 1 over root n plus 1 is divergent. Therefore, -7 is not in interval of convergence. Okay, what's the other one? X is 3, right? Check X is 3. Yeah, we get summation -1 to the n, 5n, 5n, root n plus 1. So here you get summation. The alternating factor survives. So this converges by alternating series test. Okay, this is a pretty simple alternating series. B end is positive, obviously decreasing, and the limit is obviously 0. So 3 is in the interval of convergence. All right, therefore, the interval of convergence is excluding -7, but I include 3. What else? I think I have a little weirdness going on up here that I noticed. N is equal to 0 is our beginning of our series. So this series has a serious problem with it. The first term has division by 0. How could I fix that? Well, I'm not going to sweat that kind of thing. It's just the first term that's causing a problem. Basically, what you would do is just say something like, oh, well, first term doesn't really matter. Yeah, this comparison is valid for everything past the first term. And so the comparison is eventually okay. And blah, blah, blah. Not worry about it too much. Details.